Hello guys, in this video we will see the top 9 exercise about concentrations in general. However, we will focus also on concentration exchange. Before running these 9 problems, I want to give you a trick. Let's see that. So, as you know, density helps us to go from mass to volume and vice versa. So, if we want to convert some concentration, sometimes we will need to use density. So, what I want to say is to be careful to density, because sometimes when we want to convert one concentration into another, we will need the density of solution. But when we will need it? Well, we can divide our concentrations into big groups. One group is concentration, which are expressed in mass or mole. And the second group are concentration which have volume in their definitions. When we want to convert one concentration in this group into one concentration in this other group, you will need density, because we are going actually from mass to volume. This is also true in the opposite direction. So if I want to, for example, convert molarity into percentage by mass, I will need density. And if I want to convert molality into normality, I will need, again, density. So what happens if I want to go from one concentration to another in the same group? Well, it's simple. You won't need density, okay? For example, I want to convert molarity into gram over liter. I won't need the density. Hope this was clear. This is a trick I have invented for you. And please, I also want to remind you to write all the time the definitions of concentration when you are doing your chemical problems. And now, let's go to this numerous amount of problems we have in this video. Bye bye. Let's see the first problem, which is an application problem about molality. So we have 50 grams of copper sulfate, which is beautiful blue solid, as you can see here. This copper sulfate was dissolved in 320 grams of water. Now, the question is, what is the molality of this solution? Now, to solve this problem, we need to remind the definition of molality. So, molality is the mole of solute divided by the mass of solvent. The unit of measurement are mole, of course, and kilos. Always write your definition, because this will help you to solve the problem. So what we have and what we do not have, we have the mass of solvent, it's here. However, you have to remind that we have to convert this in kilos. Let's do it. So it will be 1.320 kilos, okay, because this was in grams. Now we have just to divide it by 1012 kilos. But we don't have the mole of solute. But as you sure know from basic chemistry knowledge, mole can be easily calculated by the formula grams, mass in grams, divided by the molar mass, which is gram over mole. So in our case, with copper sulfate, this mass is 15 grams, and the molar mass of copper sulfate, you can calculate it using periodic table or just Google it and you will find that this mass is 159.5, which is equal to 0.094 mole. So now we have our unknown amount. We will put it here in the definition of molality, and we will have the answer to our problem, which is 0.294 mole over kilo. Now let's move on to the second problem. Let's see this second problem. Also, this problem is very simple, but let's do it to practice. We have a solution which is made with 54 grams of phosphoric acid, which were dissolved in 555 milliliters of total solution. Now, the question is, which is the molarity of this solution? So, as usual, to solve this problem, we need to remind what is molality. Molality is mole of solute divided by volume of solution. So we have here mole and here liters. Please remind the unit of measurement. So let's see what we have and what we do not have. So we have the volume of solution as data of this problem. It's already here. The only thing to do is to shift this from milliliter to liter just by dividing it by 1000. So it's 0.455 liters. What we do not have is the mole of solute, our phosphoric acid. But this is very simple to know because we have here the grams of our solute. So as we have done also in the first problem, the mole of our solute will be given by the mass of solute divided by molar mass. The mass of solute is 54, and the molar mass, you can calculate it or Google it if you're lazy, and it's 98.0. This is equals to 0.551 mole. So let's put it here. And let's see this calculation, and the answer is 1.21 mole over liters. So also this problem was very simple, just to start. And now we will go to third problem, which is a little bit more tricky. Let's see the data. We have a solution which is made by 67 milliliter of ethanol in 0.850 liter of solution. The question is, which is the molarity of this solution? I missed one data, which is the density of ethanol, of pure ethanol, which is 0.789 gram over milliliter. So again, please write the definition of molality so you won't do mistake. So mole of solute divided by volume of solution, and please write also the unit of measurement so you can avoid again to do mistake. So now you have everything, okay? So you just need to see which data you have and which data you need to calculate. So which data we have? We have the volume of solution, okay? Because it's here. And this time we have also the right unit of measurement. It's already in liters, so we don't have to convert it. So we miss the mole of solute, so the mole of ethanol. Okay, so again we miss one data, and again the mole of solute. So this time our data compromises the volume of ethanol. So we don't know the grams of ethanol because ethanol is liquid, so generally it's more easy to have the volume of ethanol and not to have the mass of ethanol because it's liquid. So for liquids you won't use the scale, but you will use the glassware you have in the lab to measure the right volume. So we need anyway to know this mole of solute. But as you can see here, we have density. And what is density? Density of pure ethanol, okay? So it's giving us the density of pure ethanol, not the density of solution. Density of solution won't be useful in this case. So we are lucky, the problem is giving us the right data, as usual. Problems all the time give us the right data, okay? So what is the density? Density, it will be the mass of ethanol, in this case, divided by the volume of pure ethanol, okay? It's pure ethanol here and pure ethanol here. And so as you can see here, now we can have the mass of ethanol just doing density multiplied by volume of ethanol, okay? So this is equals to density is 0.789 gram over milliliter multiplied by the volume of ethanol, which is 67.0 milliliter. In this case you don't need to change the unit of measurement because density is expressed with milliliter, so we don't need to change anything. So if you do your maths, you will see that the answer is 52.9 grams. So as usual, you can convert grams in mole just using the molar mass. So mole of ethanol, it's the mass of ethanol we have calculated divided by the molar mass of ethanol. Now the molar mass of ethanol, as usual, you can calculate it by periodic table or again just Google it. And you will find that it's 46.0 grams over mole. So the mole equals to 1.15 mole. We have now the mole of ethanol, the last unknown amount we need to know, and so we can put it here and we will easily find now the concentration, which is 1.35 mole over liter. And this is also the answer to our problem. I will erase it now to go to the fourth problem. So this problem is about calculation of normality. Let's see the data. We have 137.1 grams of BaOH2 in 500 milliliter of solution. The question is, what is the normality of this solution? So again, let's write our definition of normality. Normality is equivalent of solute divided by volume of solution in liters. This is our definition. What we have and what we do not have. So for sure we have the volume of solution, which is this one. So let's write it. Let's write what we have so we don't have to think about that again. Volume of solution is 500 milliliter, we need liter, so just convert it in liter. We have done already one step. Next step will be to know the equivalent. This is the last thing we need to know. So to do that, just remind yourself what is equivalent. So as I told you during my video about solution and concentrations, I told you what is equivalent. And equivalent, you can write it as number A, which is integer number, multiplied by mole. So A is 1, 2, 3, and so on. If A is 1, of course, equivalent is equal to mole. So just calculate mole. And then let's see what is this A, and we will have equivalent. So mole of BaOH. 2 is very simple, we have done plenty of time. It's as usual the mass of your solute divided by its molar mass, which you can calculate, and the mass of solute is 137.1 grams divided by the molar mass of barium hydroxide, which is 171.3. So if you do your maths, you will see that this number is 0.800 mole. Yes, we have the mole. If we wanted to calculate molarity, it was sufficient to have just mole, and then you have already volume of solution, and you have already molarity. But this problem is asking us normality, so we need to do one step more. And we need to see what is the behavior of this barium hydroxide in water, which is its solvent. So barium hydroxide in water will be split into Ba 2 plus 2 OH minus. So what is the total charge? The total charge is 2 plus and 2 minus, so of course it's 0 if you do the sum. So this means that the reaction is balanced. And so we have our number, our integer, which is actually 2, which is the charge is released by barium hydroxide in water. It's 2 plus and 2 minus, so A is actually 2. So we have our A, and so now it's very simple to calculate equivalent, because based on this equation, equivalent is our A, 2, multiplied by our N, which was 0.800. If you do that, you will see that it's 160 equivalent. So we have our last number to put here. We can put it directly. Just do this ratio and you will see that the answer is 3.20 equivalent per liters. So this was also a simple problem. However, you have to remind yourself what is equivalent, okay? So equivalent is A multiplied by the mole. And to know this A, you have to consider the reaction your reagent is doing in the solvent you're using, okay? So it can be A, can be related to the charge, but also if you have redox reaction can be related to the number of electrons. I recommend you to watch my video about solution and concentrations to have more insights about that. Now let's move on to the fifth problem. So let's go to see this fifth problem. In this fifth problem, we will learn how to go from one concentration to another. So this is very important in the lab. Let's see that. Okay, so we have a solution which is 36 mass percent of NaOH. The density of this solution is 1.39 gram over milliliter. This is mass over mass, okay? Percent. And the question is what is the corresponding concentration in gram over liter of this solution, and which is the corresponding concentration in molarity. So basically we have to go from percentage by mass to gram over liter or to molarity. How to do that? Okay, as usual, write the definition of all of them. So let's write the definition of mass percent, which is mass of solute divided by mass of solution times 100. We have the first one. So the second one is gram over liter, which is mass of solute divided by volume of solution in liters. This is gram. Okay, so how to go from this one to this one? It's very simple, just see what we have and what we do not have as usual. So we have the mass of solute. Well, apparently not, because we have just 36%, so we know just this. We have the volume of solution, no. So actually it looks like we cannot answer to this problem. But let's use a trick. Let's go to see a little bit better how we can write percentage by mass. Okay, percentage by mass in this case is 36%, so it means that I can write that I have 36 grams of NaOH in 100 grams of solution, which is NaOH plus water times 100. Why this equation is true? Because if you simplify this, you will have 36 equals to 36. Oh, this math, so this is true. So I can pretend I have 36 grams. Okay? Just pretend it. I have 36 grams of NaOH. And now we have only one unknown amount, which is the volume of solution. Okay, we know the mass of solution because with this trick I told you, we are considering 36 grams in 100 grams of solution. So I can consider 100 grams of solution, and through the density I can calculate the volume. Let's remind us what is density. Density of something is related to something, okay? So density of pure ethanol means mass of pure ethanol divided by volume of pure ethanol, okay? But density of solution means mass of solution. Let's write it. Divided by volume of solution is all the time on the top the same things you have on the bottom of this equation. So mass of solution is 100 grams divided by volume of solution equals 1.39 grams of milliliter, which is the density. So volume of solution is 100 grams divided by 1.39 grams of milliliters. This will be simplified, and you will have the answer to that is 71.9 milliliter. This means we have now the answer for this. Just put it here. Of course, all the time you have to remind unit of measurement. Here is liter, okay? So we have to convert this in liter. So it's 0.0719 liters. And you will have the answer to this problem, which is, it's about 100.4. grams over liter. We got this. Now let's try to answer this molarity. Okay, what is molarity? Okay, we'll keep this. I will write it here, molarity. In this case is mole of NaOH divided by volume of solution. So we have to go from this to this now. How to do that? Again, let's consider the mass of the percentage by mass as 36 grams of NaOH over 100 grams of solution, and it's done because 36 grams, if you divide it by the molar mass of NaOH, which is 40.0 grams over mole, you are calculating this amount. And if you divide it from the volume of solution, which is exactly the same we have done here, it's the same calculation we have already done for this one, for this guy. Just put this number 0.0719 liters and you will have the answer. Just do this calculation. And the answer is 12.5 mole over liters, because this will be simplified. I hope this problem was clear. It's very important to understand that for converting percentage by mass into molarity or gram over liter, you need this guy, you need density. But density of what? Not the density of the solute, okay? We don't need that. We need the density of solution. Otherwise, I cannot calculate from mass of solution, I cannot calculate the volume of solution, okay? For that, I need the density of solution. Keep this in mind and let's move on to the next problem. Let's move to the sixth problem, but let's change also the blackboard because I was bored of the old one. So let's write the data. We have 4 molar solution of nitric acid. The density is 1.13 and the molar mass of nitric acid is 63 gram over mole. So those are the data, and let's see what is the question of this problem. So the question is, which is the percentage by mass and which is the molarity of this solution. So the problem is asking us to convert from molality to percentage by mass and to molarity. So this can be very useful in the lab, because in the lab it's common, you have to convert from one concentration to another. Now let's remember us what is percentage by mass and what is molality. So let's start from molality. Molality is the mole of solute divided by the mass of solvent in kilos. Let's frame that. Now, the percentage by mass is mass of solute divided by mass of solution times 100. Let's frame also this one. And now let's try to find the answer to this problem. First of all, we have 4 molar solution. This means that we have 4 mole of nitric acid in 1 kilo of solvent. So we are just using the definition of molality to write this second equation. So what to do now? What are the data that we need? We need to know the mass of solute. This is mass of solute, I did a mistake, but it's mass of solute. And this is mass of solution. So we need to know the mass of solute. But here we know only the mole of solute. This means that it's very easy to go from mole to mass by using the molar mass. What we have to do is, for knowing the mass of solute, we have to apply the basic of chemistry and wrote that 4 mole times 63 which is the molar mass, equals 252 grams, which is now the mass of a solid. So now we have the first datum. Let's go to the second one, the mass of solution. Please remember that mass of solution is mass of solute plus the mass of solvent. The mass of solute, we have it here, we have already calculated, and the mass of solvent, it's here, it's 1 kilo of water, it's written here. Of course, we have to convert this from kilos to grams because we are writing now the mass of solute in grams. And the percentage by mass is independent by the unit of measurements, but you need to keep them in coherent form. So I cannot write kilos here and grams here, it will be incorrect. So use the same unit of measurement. Let's move on and do this calculation of mass solution. So the mass of solution is 1000 grams plus 252, which is 1252 grams. Now we have all the data to calculate the percentage by mass. Percentage by mass is 252 divided by 1252 times 100. Everything is equal to 20.1%. So we answered the first question, we got it. Yeah, but now it's not finished. We need to know what is molarity. So it's not time to celebrate yet. Let's move to the second question. For the second question, we need to remind us what is molarity. So molarity is mole of a solute divided by volume of solution in liters. As usual, please remember the unit of measurement. So let's frame the definition, and now we can try to answer. The mole of solute, we have it already, it's 4, so let's write it. It's here. Okay, let's write it. 4 mole of solute. Now we need to know the volume of solution, but some job we have already done, because we know that we have 1 kilo of solvent, and we know already that the mass of solute is 252, because we have it calculated before. We know the mass of solution, and it's 1252 grams. So what we have to do is to convert the mass of solution in the volume of solution. How we can do that? We can do that using the concept of density. Let's remember what is density. The density of solution is mass of solution divided by the volume of solution. Please, all the time you have the density, try to understand what kind of density you have. Now we have the density of solution, okay? Density of solution means mass of solution divided by volume of solution. If we had a density of, for example, pure water, which is 1, then the density of pure water means the mass of pure water divided by the volume of pure water, okay? So please take this into account. In this problem, to convert the mass of solution into the volume of solution, we need the density of solution, so this information is correct. So the volume of solution, it will be equal to the mass of solution divided by the density. Let's put inside the numbers. Divided by 1.130 gram over milliliter. So the answer is 1108 milliliter. Of course, we have the volume in milliliter because density is expressed in milliliter. But the volume of solution is in liters, so just convert this into liters by dividing it by 1000, and you will have 1.108 liters. So the answer of the problem is 3.61 mole over liter. And as you can see, from going from molality to molarity, we need to know the density, okay? Whereas when we need to go from molality to percentage by mass, in this case we don't need density. So also this problem was done. Let's move on to the seventh one. Let's see the data. We have 3 molar solution of sulfuric acid. The density is 1.18. The molar mass of sulfuric acid is 98 gram over mole. And the question is, which is the molality of this solution and which is the molar fraction of this solution? So this time we have to go from molarity to molality and molar fraction. Let's start as usual from definition of molarity. Molarity is mole of solute divided by volume of solution in liters. Let's frame it as usual. And then we need to go from molarity to molality. So what is molality? Molality is mole of solutes. It's the same as molarity in this case, but it's divided by the mass of solvent in kilograms. Okay, so we have both definitions, and what we can say that 3 molar solution is 3 mole of sulfuric acid, which are in a volume of 1 liter. So we have already the mole of solute, so we can write it. It's 3 mole. What we need is the mass of solvent. We have the mass of solution, but we do not have the mass of solvent. So how to calculate the mass of solvent? So the mass of solvent is given by mass of solution minus the mass of solute. So it's easy. But how we can calculate the mass of solution? As I have already told you, molality and molarity are connected one each other through the density. Okay? So we have to use the density. We have the density of solution of sulfuric acid. So density is mass of solution, in this case, divided by the volume of, again, solution. And this entails that the mass of solution equals density times volume. So the mass of solution is 1000 milliliters times the density, which is 1.18. Why I wrote 1 milliliter? Because density is expressed in milliliter, okay? So I just converted the volume of our solution, which is 1 liter, in milliliter. So just do times 1000 and you will get it. So this is 1180. So now how to calculate the mass of solute? Because we need also the mass of solute. We know now the mass of solution, but we need also the mass of solute. And the mass of solute is easy to calculate because we have the mole of solute. So we have just to multiply this by the molar mass of the solute, which is sulfuric acid, and so is 98. Let's do it. So it's 3 mole times 98, which is 294 grams. This means that mass of solvent will be 1180 minus 294, which is 886 grams. So we need just to convert these grams in kilos, because molality is in kilos, and we have our solution, which is 3.39 mole over kilos. So this is the molality. Now we need to calculate the mole fraction. So how to do that? Let's remember what is mole fraction. Mole fraction is the mole of solute divided by the mole of solution, if we are considering the mole fraction of solute, okay? So this is our definition. So let's see what we have and what we do not have. We know that 3 molar solution of sulfuric acid means that we have 3 mole of sulfuric acid in 1 liter of solution. Let's write it again, okay? to know the mole fraction of solute, we need the mole of solute. Okay, my mole of solute is 3, so let's write it. It's 3, the mole of solute, so we have it. What we do not have is the mole of solution, so we need to calculate that. How we can do? We know that the mole of solution are equals to the mole of solute plus the mole of solvent. The mole of solute, we know it. What we need to know is the mole of solvent. We have done before the mass of solvent. We have done already this calculation. And we have already said that the mass of solvent is the mass of solution minus the mass of solute. So we did all of this calculation, if you remember. So we calculate the mass of solution using density, and then we calculate the mass of solute using molar mass of sulfuric acid, and it was 294. The mass of solvent was equals to 886. So we have done it before. We know already the mass of solvent, so now it's easy to go from mass of solvent to mole of solvent, just using the molar mass. So the mole of solvent will be the mass of solvent divided by the molar mass of the solvent, which is water, so it's 18. So it will be 886 divided by 18, which is 49.22 mole. So we need just to add this to the mole of solute to gain the mole of solution, and which is 52.22. So let's write this in our definition of mole fraction of solute, and we will have the answer to our problem, which is 0.057. So now we need to know the mole fraction of solvent. How to know the mole fraction of solvent? The mole fraction of solvent is actually simple because it's 1 minus the mole fraction of solute. This is because we are dealing with fractions, and this is property of fraction, okay? You can all the time, to obtain one fraction, you can subtract the whole to the fraction of the other one. So it's very simple. And the answer will be 0.94. So we did also this 7th problem. I hope everything was clear, and now let's move to the 8th one. So let's see the data. We have 26 grams per liter of potassium sulfate. The molar mass of potassium sulfate is 174.2, and the question of this problem is what is the molarity and what is the normality of this solution. So what we have to do is to go from gram over liter, which is a way to express concentration, to go from this to molarity and normality. So as we usually do, let's see again and again the definition of gram over liters, and then the definition of molarity and normality. So gram over liter is the mass of solute in gram divided by the volume of solution in liters. Let's frame it, and then let's see what is molarity. Molarity is the mole of solute divided by volume of solution in liters. Let's frame also this one. And now let's think about what we have and what we do not have. So we have 26 gram over liter. This means that we have 26 gram of potassium sulfate, so our solute, in 1 liter of solution. Okay, because this is the meaning of a gram over liter. So you can write this one in this manner in order to understand what we have as data, okay? And so we have 26 gram of potassium sulfate in 1 liter of solution, so in 1 liter of potassium sulfate plus water. What we need is the mole of solute, okay? Because we have the mass of solute. But to know molarity, we need to know the mole of solid. So what we need to do is just to convert mass into mole, and this is very simple. This is probably things you have to do each day in chemistry lab. So just divide the grams by the molar mass of the solid, and the answer is 0.15 mole. But let's think a little bit what we have. Now we have said that 26 grams is equal to 0.15 mole, okay? So this means that these mole are in 1 liter, because this is the solution we have. And what is mole in 1 liter? Is molarity. So guys, we have already the answer. For molarity is 0.15 mole over liter, so we know already the molarity. Now we need to find the normality. So what is normality? Normality is equivalent of solute divided by volume of solution. So it's very similar to molarity, but what is changed is that we need equivalent. And so, as I said many times, normality is linked to molarity by this equation. Normality equals n times molarity. And what is n? N is an integer which can be 1, 2, 3 or 4. So we need to find what is this n, if it's 1, 2, 3, 4, whatever, because we know already molarity. So we need just to find n, and we have normality. To find n, you have to think about your solute and how your solute is dissolved in this solution. So let's see what our solute, potassium sulfate, is doing in water. It's dissolved in 2K plus SO4 2-. So as you can see, we have potassium, which is charged 1+, but since we have 2 potassium per molecule, we will have 2+ as total, and we will have 2- for the sulfate anion. This means that the charge is 2, so N is 2. Because I would like to remind you that N is related to the charge released in solution, or can be related to the number of electrons if redox reaction is happening. So N in our case is 2. Now it's very simple to calculate normality. It's just 2 times molarity, so which is 0.13 equivalent per liter. So also this problem is done, and now let's move on to the last one. Let's start with the last problem, which is slightly longer than the previous one, but it's a recap of everything. So let's see that. So data, we have a solution which was made by 90 grams of CaCl2 in 440 milliliters of water. The density of this solution is 1.15. The molar mass of CaCl2 is 111. And the problem is asking what is the percentage by mass of this solution? What is the gram over liter? What is the mole fraction of all components? What is molality? What is the molarity? And lastly, what is the normality? So as you can see, it's asking a lot, but we can manage it. Let's start from the beginning. So from the first question. Percentage by mass, what is it? Percentage by mass is the mass of solute divided by mass of solution times 100. Let's take this in mind. And so let's see the data. We have the mass of solute. Yes, we have it. It's 90 grams of CaCl2. So let's write it because we have it. We have already one data, 90 grams of solute. However, we need the mass of solution. Okay, mass of solution is the mass of solute plus the mass of solvent. We have the mass of solute, but we do not have the mass of solvent. So how to calculate that? If you look at that, we have 440 milliliters of water. And if you remember, the density of water is the mass of water divided by the volume of water. So this entails that the mass of water is the density times volume of water. So since the density of water is 1, if you do time 440 milliliter of water, you will gain 440 grams of water. So as you can see, I used here the density of water and not the density of solution, because we need the mass of solvent, which is different from the mass of solution. So you have to use the density of, in this case, pure solvent. So this is water, yeah. So the mass of solution equals the mass of solvent, which is 440 grams plus 19 grams of solute. The sum is 530 grams. So we can write it here, just do times 100, and you will have the answer to the first question, which is 17%. So we gain the answer to this first question. We can move on to the second question. So what is the gram over liter? Gram over liter is the mass of solute divided by the volume of solution in liters. This is our definition. And so what we have, the mass of solute, we have it. It's 19 grams. Let's write it. What is the volume of solution? Okay, we do not have apparently the volume of solution. We have to calculate it. So the volume of solution is, of course, the volume of water plus the volume of solute inside. But we do not know the volume of solute, so we cannot do as we have done with mass of solution, okay? The volume of solution, we can calculate it just if we have measured it in the lab or if we have the density. And since we have the density in the data, we can use that. And now it's easy to calculate the volume of solution, because the volume of solution will be given by the mass of solution divided by the density of solution. So it will be 530 grams over 1.15 grams over milliliter. The answer is 461 milliliter. So as you can see, we have dissolved 90 grams of CaCl2 in 440 milliliter of water, and the volume of total solution is 161. So it's 21 more if compared with the volume of water. This means that when you dissolve solute in your solvent, the volume will change. This is very important. So let's write it here to have the answer. The answer will be 195 grams over liter. Of course, you have to convert milliliters in liters, because here we need the volume of solution. So we have also the second answer. And now let's find the mole fraction. So let's start from mole fraction of solute. Here we can have the mole fraction of solute and the mole fraction of solvent, because this solution is made only by two components. So let's start from mole fraction of solute, which is the mole of solute over the mole of solution. So this is our definition. Now, the mole of solute, we can easily calculate them by doing the mass of solute divided by the molar mass of solute. So it will be 90 divided by 111, and the answer is 0.811 mole. Now the mole of solution, it will be given by the mole of solute plus the mole of solvent. We have already the mole of solute, but we need the mole of solvent. How we can calculate that? Well, we have calculated before the mass of solvent, which was 440 grams. So let's just do 440 grams divided by the molar mass of water, and we will have the mole of solvent, which is 24.4. This means that the mole of solution will be given by 0.811 plus 24.4, and the solution is 25.2 mole. So we can write everything we got here. So it will be 0.811 divided by the mole of solution, so 25.2, and we will have the mole fraction of solute, which is 0.0322 mole. So how we can calculate now the mole fraction of solvent? It's very easy. Since we are dealing with fractions, you can use property of fraction. Property of fraction means that you can calculate another fraction starting from the whole minus the other fractions you have. So for example, if we want to know the mole fraction of solvent, we can do 1, so the whole, minus the mole fraction of the solid, and we will gain the mole fraction of solvent, which will be 1 minus 0.0322 equals 0.968. So with this we have answered also to this other question, and we can move on to molarity. Again, let's remind us what is molality. Molality is mole of solute divided by the mass of solvent, okay? So mass of solvent, I remind you that molality is the only concentration to have solvent on the bottom. All the other concentration, they have solution here. So this is the peculiarity of molality. So the mole of solute, we have it's 0.811 because we have calculated for the previous question. So we need now the mass of solvent. And the mass of solvent we have also calculated. It was these 440 grams. So just convert these grams in kilos and we will have the answer already for molality, which will be 1.84 mole over kilo. So we have done also these 4th questions. Now let's do the second to last, so molarity. Molarity is mole of solute over volume of solution. We have written this many times. I hope you will remember just because of all of this repetition. So the mole of solute, we have it is 0.811. Just write it. And the volume of solution, we have also calculated before for calculating grams over liter concentration. And if you remember, it was 0.461 liters. So molarity is 1.76 mole over liter. So as you can see, once you have calculated some concentration, to calculate the other one is very simple because many of the calculations you have already done. But now let's go to the last one. This is done. Last one, normality. Normality is equivalence of solutes divided by volume of solution. Yeah, let's frame that. So normality is linked to molarity by this equation, 9 times molarity. And 9 is integer, which can be 1, 2, 3, 4, and whatever. So the only problem to find normality is, since we have already molarity, is to find this n. As I have already said many times during this run of problems, is that this n is linked to the chemical equations about what the solute is doing in solution. Our solute is calcium chloride. Now calcium chloride in solution is giving rise to calcium cation, which is 2+, plus chloride anion, which is minus. But we have 2 chloride anion, so it's 2 minus here and 2 plus here. So as you can see, this calcium chloride is releasing in solution a charge which is 2, okay? 2 plus and 2 minus. And actually this is our n, because n can be the charge or can be even the number of electrons if you will have redox reaction. So just think about what your solute is doing in solution and you will find your n, and if you find n you can find the normality, because normality can be found by molarity if you have it, or you can find normality just doing n times the mole, so it will be n times the mole, which will give you equivalence, and then divide by the volume of solution. But since we have molarity, we will use this equation here. So n is 2. So 2 times molarity will give you the answer to this problem, which is 3.52 equivalence over liter. So we have done also the last problem. And we've done the last problem of this series. So I hope it will help you. We have done it. You can celebrate. I can celebrate. And bye bye.